find the molality because you don't have the compound, like what kind of compound it is. So
All right, let's take a look. Calculate the molecular weight of a compound if 4 grams of it plus 50 grams of water give a solution with a boiling point of 100.41 degrees Celsius. So with this, what we're going to have is this is our 0.41 is our delta T sub B. Let's see what else we got.
you're not sharing your screen.
I'm not. It's a secret screen. Give me 1 second. There we go. So this 0.41 grams, I'll zoom in a little bit on that for you. If I can. 0.41 degrees Celsius, that is our change in temperature, we're boiling. You get that from taking 100 and subtracting it from this, because we are dealing with water. Now this 50 grams, that is our mass of the water. So we have, if we take a look, let's do this, 0.0512 kilograms, right? And we have, let's see here, we have 4 grams of this stuff. So we have here X equals this times, and this will be the moles. So X equals divided by that, the kilograms, and this is the delta T, it should be, let me put out the formula over here, how I'm doing this, is I m KB. We also need the KB for water. What is that? 0.512?
Yeah. And you're doing X mole divided by the kilograms because that's molality, right?
Yes. Right? So we have 0.41 degrees Celsius is the delta T sub B. The I, because it is a molecular compound, is 1, so we don't have to worry about that. We've got the kilograms of the water. We've got this. So in order to solve for X, I need to multiply this by 0.05 and divide it by 0.512. Is that correct? 0.41 times 0.05 divided by 0.512. That gives me 0.0400 moles. What is the molar mass?
4 grams.
No, molar mass is the mass or grams per mole. I know how many grams I have. And I know how many moles I have. So the molar mass by definition is mass per mole, right? And I have the mass and the moles. So all I got to do is take 4 divided by 0.0400. And we get 100. If you would have used this, I'm sure, 4 divided by 0.0400390625, get 99.9. I rounded. I shouldn't have rounded, but right, I guess. So let's do this. Let's just take it out there. 99.9. Olivia, does this part make sense? The definition of molar mass?
Yeah.
Yeah. I know that this isn't the kind of math that I'm used to either, but I can't think of any other way to like play this out other than making the moles up here be the X. It's not, these colligative properties are not the math that we like to do with the dimensional analysis, unfortunately. They do have these set formulas, so we have to go back to our algebraic roots.
I just don't understand why you multiplied 0.41 times 0.152 and then divided by 0.05.
So if this is X, then this is on, like you could do this as well, right? And so this is on the bottom of this side, so I want to multiply both sides by 0.05. And since this is on the top of this side, I want to divide both sides by 0.512 to solve for X, right? Maybe I can write this out better. So this equation right here, I'm going to rewrite it. And I'm not going to put units. But basically what this is 0.41 equals X times 0.512 over 0.0500. So how do you solve for X here? You multiply by the 0.05 and you divide by the 0.512.
Oh, okay, that makes sense.
Yeah. So it's what is the name for that algebra? What is it? Yeah, you want to isolate X probably. Math teachers have so much better ways of saying that stuff than me. Yeah, isolate the variable. But yeah, so X is here. So we multiply both sides by 0.05 and divide it by 0.512.
Okay, thank you.
Mm-hmm. There's another one on the back of this page, number 8, that's very similar to that, except they use freezing point instead. So if you want to try that out, that may be a one that helps. Any others 1 through 6, or did I give you guys a specific?
Only the even ones you said.
Only the even ones. So any 2 or 6? Are you guys good on those? Did you get the answers? I'll post, if you didn't get these answers or whatnot, I'll post up the work probably over the weekend. I just realized I did not have it all. So I wasn't able to get it. Get it. I gotta find this sheet wherever the answer key is from last year for this sheet. I don't have it. With those colligative property things, you can expect out of the 4 different things for a testing situation, I would pick either freezing point or boiling point, and then either an osmotic or a vapor pressure problem. So you could expect probably out of that 2 problems.
Will you do a vapor pressure problem, please?
Yep. Is there any on this page?
I think number 1. Or
Well,
was that?
we did number 1 yesterday, didn't we?
No.
I did. I did for one class at least. Is number 1 the only vapor pressure problem in there? Yep. All right. So the deal with vapor pressure problems, let me grab, this looks like I have your period 9s here that I'm working on. Let me grab your guys's and I'll do it real quick. So if we take a look, the vapor pressure of ethanol is at 40 degrees Celsius is this. So this is our P prime or P standard, right? It then says calculate the vapor pressure of a solution of 53.6 grams of glycerin in 133.7 grams of ethanol. So right there, we know that we're looking at the vapor pressure of ethanol. So this is our solvent. So remember, we need to get the X of the solvent and then multiply it by this P naught here. So the X is the mole fraction. So the first thing I'm going to do is I'm going to find the number of moles of ethanol. 2 times 12.01 plus 6.06 plus 16.
It's 46.08.
So that right there is the molar mass of ethanol. (133.7) divided by 46.08.
It's about 2.9014.
Wait, what did you just do?
Molar mass. So I have the mass here. I divide
Yeah.
it by this and that gives me the number of moles.
Okay.
I divided 133.7 divided by 46.08. Right? Good. Now I got to find the moles of glycerin. 3 times 12.01 plus 8.08 plus 16 times 3.
It's 92.11.
So I'm going to take this 53.6 and divide it by 92.11. 53.6 divided by 92.11.
The answer is about 0.5819.
Why don't I have an
Sorry.
index here? Why am I not multiplying this by anything?
Because it's 1.
Because it's 1. C3H8O3 is molecular, so it's 1.
Sorry, Mr. Jackson. I like missed that. Where did you get that second number?
This is the molar mass of glycerin. And we have 53.6 grams of glycerin. So again, remember the mole fraction is moles. Here, moles of solvent in this case over total moles. So this is the moles of glycerin. 53.6 divided by 92.11. 0.5819.
Why wouldn't the glycerin be the moles on the numerator?
What?
Why wouldn't the glycerin be the moles of the numerator? Like, why is the ethanol on the top?
Because it says we're looking for the vapor, it gives us the vapor pressure of ethanol.
Oh,
So that tells
okay.
us that that's the solvent. Good. Yeah, there's a lot going on with these colligative property things, really. And I mean the thing is, yeah, like that's how we know that this is a solvent. And then, you know, if you don't know that, then yeah, you can't move forward on the problem, right? 0.581913 plus 2.90148.
That would be about 3.4833.
That's one of the problems with using the watch is that with these problems, you could have all these numbers already in your calculator, right? 2.90148 divided by 3.4834.
That would be about 0.8329.
0.8329 times 135.3.
It's about 112.6913.
They gave you the tour here. They could have given you atmospheres here. Oh yeah, that's one thing I wanted to talk about yesterday. You guys let me go through it. I typed in 0.821 on this. So instead of being 367, it should be 36.7. You might want to make sure that you change that if you go in and look at that later. Whenever I did this, I typed it in as 0.8 instead of 0.08. And you guys let me. How dare you know? What do you think?
How do we know to use 0.0821, like when it's ATM?
Oh, so you have to go back to last semester and those are constants. So this osmotic pressure here, they wanted in atmospheres, so you use the R constant. I mean, if you wanted in atmospheres, you use the R constant 0.0821.
How did you know you wanted an atmosphere? It was like on the test of the answer.
You could do it in whatever you want. But let's take a look here. This one they did in Tor, right? So instead of using 0.0821, you'd use 62.4. I'm not sure why they did this one in Tor, but they did. Here you had to use it because you weren't finding, you're actually calculating the molarity, and they gave you the pressure in Tor. So you'd either have to change this Tor to atmospheres or use the 62.4.
Isn't it like 760 torr equals like
One
one atmosphere?
atmosphere. Yep.
Okay, just wanted to make sure.
Yep.
What is the like label for vapor pressure? Like what do you put after the number?
For vapor pressure, basically, this right here is a mole fraction, right?
Mm.
So this is moles over moles, which cancel out, and it gives you a decimal.
Oh, so you just use pressure?
Then you multiply that by this 135.3, which has a unit torr. Whatever
Mhm.
unit pressure they give you here on the standard pressure, that
Yeah.
becomes your unit.
Okay, thank you.
You're welcome. Yeah, you want to do number 6? The question is, we want to do number 6. Did you do it last? You didn't do it last night because baseball. So let's take a look at number 6. If we take a look, it says calculate the osmotic pressure of a solution made by adding 13.65 grams of sucrose to enough water to make 250 milliliters of solution at 25 degrees Celsius. So right away, we're going to change that to Kelvin. Right? That's the symbol for osmotic pressure. And if you recall, it equals IMRT, I believe. Immert. IMRT. Under piada table. So this is sucrose, so that's C12H22O11. What is our I index for that?
1.
1 is correct. 12 times 12.01 plus 22 times 1.01 plus 11 times 16.
It's 342.34.
I have a question.
Yeah,
So is the M in this case uppercase as in like molarity?
it is. That is molarity. Good call. Yep. So if we take a look, 13.65 divided by 342.34.
That would be about 0.03987.
And it's to make enough solution to make 250 milliliters of solution. 0.0398726 divided by 0.025.
The answer is about 1.5949.
So that's 1.595 molar. Our index we set as 1. The R constant, I'm going to go ahead and go with atmospheres because they have atmospheres for that. So 0.0821 atmosphere liter per mole Kelvin. And then we need to multiply it by 298 Kelvin.
Wouldn't it be 0.25 liters, not 0.025?
Oh, good call. So it's not 1.59, is it? Thank you. That saved me from going back and saying, what? 0.039873 divided by 0.250.
The answer is about 0.1594.
So that'll be 0.1595. 0.15942 times 0.0821 times 298.
It's about 3.9003.
And we get 3.90 out. Others? All right. Was the first bell ring yet? No. Okay. So let's try one of these combining stoichiometry and molarity problems. So if we take a look, it says calculate the mass of silver sulfide produced when 125 milliliters of a 0.200 molar silver nitrate is added to excess sodium sulfide. The equation is this. So we want grams of silver sulfide in the end. So which of these has 1 unit?
Milliliters.
Milliliters. So if we start with 125 milliliters of silver nitrate, every 1,000 milliliters of silver nitrate is 1 liter. Every 1 liter has 0.200 moles. This is basically, if you never got this type of math, then good luck. I mean, this is what we've been building up for. This is moles of silver nitrate. And every 2 moles of silver nitrate make how many moles of silver sulfide? 1 mole of silver sulfide. And for every 1 mole of silver sulfide, (107.87 times 2 plus 32.06).
The answer is 247.8.
247.8 grams. And then you plug all that into your calculator. 125 divided by 1,000 times 0.2 divided by 2 times 247.8.
The answer is 3.0975.
3 significant digits. So 3.10 grams. And silver sulfide. So what is the only new step? Well, take a look from here. That right there is the old stuff that we're used to. You get the number of moles and you find the number of grams, one substance to another substance. The only change now is that you are going from molarity or milliliters or something like that. So here, what is the mass? That's the same exact type of problem. Using the equation below, what is the mass? A sample of this is reacted with this. If that many grams of precipitate formed, what is the molarity? 5 right here. So this one wants to know the molarity. Did they give us a balanced equation? Didn't look like it. So we need to make a balanced equation. Na2SO4 plus BaCl2 yields. What type of reaction is this? Compound, compound, compound. Yeah, compound, 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 compound. That's double displacement. We need to balance that. So it says we want a molarity. How many units does that have?
Two.
2, right? There's 2 ways we could do this. In reality, for this, we could start with the grams on top and the milliliters on bottom. We wouldn't do anything to the milliliters until the end. I probably would not even do that. If I know the grams here, 5.28 grams of this barium sulfate, I can find the moles of the Na2SO4, and then from knowing the moles, I have the volume of the solution. I can take and find the molarity of that. But basically, where's barium? 137.33 plus 32
I
point,
didn't get that. Could you
137.33 plus 32.04 plus 0.02 plus 4 times 16.
It's 233.39.
No, I think that that's probably right. 233.39 grams per 1 mole of the barium sulfate. Every 1 mole of barium sulfate needs how much sodium sulfate? 1 mole. And every, oh, look at that. That'll actually get me moles. I don't need to use the molar mass for the other one. 5.28 divided by 233.39.
That would be about 0.02262.
That's moles. And then I'm just going to take that moles and divide it by liters. 0.022623 divided by 0.250.
It's about 0.09049.
0.0905 molar. Not sure why they only did 2 significant digits. Oh, 250. Yeah, boom. Whatevs on that. Change it to make my needs. But that's stoichiometry with this. I would suggest you do 2, 3, and 4. I'm sorry, 2, 3, and there is no 4. 2, 3, and 6 for this evening. Huh? For the end of the half, right? Don't leave yet, because we do have one other requirement that we want to do today to help out the people that are help me out here, that are going to be coming into the laboratory tomorrow. So Friday we have a group quiz. So we will have to get that done during class period on Friday. That is the 9 weeks quiz. It is over the concentration stuff that we finished up on Tuesday of this week. So yep, the 9 weeks quiz is a group quiz. Basically, I made that decision earlier today because I did not want to having to grade all of those. So I did have to switch that. It just wasn't going to work out if I gave you until Monday to finish it. You got it. Yep, in 2 days. I would not have been able to get those graded and put into the book like I wanted to. So I thought, let's make this easier. We'll make it a group quiz, and that'll be that. But tomorrow, we want to. Why isn't this printing? Print, darn you. Tomorrow we wanted to. This thing stinks. To have those people make a solution. So next week we are doing what's called using a spec 20. Now we all know that light can go through many solutions. You can shine light through liquids and stuff like that. If you shine light through pure liquids, give me 1 second. I'm starting to see why this won't let me print this, and it doesn't look like it's going to happen anyway. So I'm just gonna have to share this part of the screen with you guys. We can share light, shine light through liquids. If we shine it, it's not an interval, right? This is just a second half hour period, right? Yeah. If we shine light through the pure solvent, and we take a reading of that, and then we shine light through a solution that we know, certain amount of that light will be absorbed. By knowing that amount of absorption, let's say we shine the light through even more concentrated solution, then more of that light will be absorbed. And if it's less concentrated, if it's dilute, then less of that light will be absorbed. So by measuring the amount of light that's absorbed as we shine it through a solution, we can make a baseline for their concentrations. We can make a graph that basically says concentration to absorbency. We know that as the concentration gets higher and higher and higher, more and more light will be absorbed, right? Well, it is something that it makes a straight line. Pretty cool, right? The problem with that is we also know that certain wavelengths of light are different colors. The colors that we use most of the time are the visible light spectrum. So next week, what we're going to do is we are going to take a solution that they make that's based off of this right here, and we are going to use that. Now, I have never done this before. Had the students make it. Usually I make the solution, but we usually also do this big, huge lab write-up that we're not doing. So the only way that I can get students to make solutions this year, I think, is to have them make the solution needed for this laboratory. So what we need to do then is we need to find the concentration of that stock solution that I normally make. Now this is going to bring us into, again, hydrates. So the solution, the chemical that you guys are going to be using is cobalt 2 nitrate hexahydrate. They are making 25 milliliters of that solution. I am going to have you guys make 100 milliliters, I think, instead. 1, 2, 3, 4, 5. The reason for that is 5 times 5 is 25. 25 won't cut it. We need more than 25. And we're going to introduce a new piece of equipment. Let me grab one real quick. A new piece of equipment for you guys is the 100 milliliter volumetric flask. There is one line, and that one line is 100 milliliters. That means that whenever you're adding water, when you start to get to here, you may want to get a dropper out, right? If you're trusting your hand strength with the distilled water thing, you might go over. If you go over, well, this solution has error then. So that's fun. So let's take a look at this. The stock solution of cobalt 2 nitrate hexahydrate was prepared by dissolving 1.462 grams of solute in 25 milliliters of solution. So what do we need to do to find molarity?
Convert to moles and liters.
Yeah, right. Convert to moles and liters. So this should not be that hard.
Mr. Jackson, this packet I don't see on Canvas.
This is actually under the laboratory.
Okay.
So it's under what's called the Spec 20 lab. It says it's published. And this is what we're doing in next week, right? So I'm going to switch to this paper so I can work this problem out because I'm not able to. Oh, it's letting me print now. Don't save as PDF, print to that. Boom. I'm gonna go grab that off the printer real quick, and then we'll solve it. Right? Oh, stupid. All the stupid information sheets we're printing out first. You guys have probably already solved this, right? Anybody got the molar mass for me? No? 6 times 16 plus 2 times 14.01 plus 58.93.
The answer is 182.95.
6 times 18.01. Ooh. 6 times 18.02.
That would be 108.12.
Wait, so it's the molar mass of both the hexahydrate and the cobalt to nitrate?
Yes. Yep. Right here. Remember,
Okay.
waters are included in the molar mass of the hydrate. Yep.
Okay.
One oh eight point 12 plus 182.95.
The answer is 291.07.
291.07. Mole. Wait, grams per mole. Ugh. Grams per mole. So we had 1.462 grams for every 0.02500 liters of solution. I just did that in my head, right? I changed the 25 to that. Every 291.07 grams is 1 mole. 1.462 divided by 0.025 divided by 27. My 9s look like a 7. 1.462 divided by 0.025 divided by 291.07.
That would be about 0.2009.
09. Molar. And here's the thing. So that would be how we would make this molar solution. So what you want to do is you want to make a solution. Those of you that are coming in tomorrow, you want to make a solution that is 0.200 molar. You want to get as close to that as you can. You're not going to necessarily get that, right? But you need to make a procedure for the rest of the class, at least. You need to make a procedure on how to get that. You want 100 milliliters of that solution. So that means that, how do we make this then? Well, you've got to find the mass that you'll need to add enough water to equal 100 milliliters of solution. Does that make sense? You want grams? How many units does that have?
Two.
How many units does grams have?
Oh, one.
1. So out of these two things, what will we start with? This is a totally separate problem here. I just want to make sure. This is where I'm doing my work. So out of this, are we going to start with moles per liter or milliliters?
Milliliters.
Milliliters. So we'll start with 100 milliliters. knowing that we want a 2.2 moles per liter solution, and we want to solve 4 grams. That's the first step in making our procedure. Once we get this amount of grams, then all we need to do is tomorrow, Olivia and those of you coming in, you have to measure out that amount of grams. You probably won't be exact, which means that you won't have a 0.200 molar solution, but it will be, you'll have your solution and it will be close to this. But that will now be the molarity of your solution as you go through this lab next week. Does that make sense? If I make Kool-Aid and you make Kool-Aid, they might taste a little different, right? Mine may be more sweet or less sweet. We both wanted Kool-Aid. We all want this 0.200 molar solution. But based on what we actually measure in the laboratory tomorrow, that's going to be the factor that affects what the actual true molarity is. It doesn't matter. If we're off by a little bit, we use that new molarity in everything we do for the rest of the laboratory.
Wait, so for the amount of grams we find of the solution, do we subtract that from the 100 milliliters?
No. Yeah, this is the fun part, Olivia. You add enough water to make 100 milliliters. So however much water it takes, you add that much. So even though we're saying 100 milliliters, that's the final volume we want of our solution, right? It's not 100 milliliters of water. It's enough water to make 100 milliliters. And this is where, when talking about it, it's going to be very, very fun, I think. So what I want to do is I want to bust you guys into groups. How many people do we have come on those days? I'm just going to break you guys into 4 groups.
We usually have 5, but sometimes not everyone comes.
All right, so I'm going to bust you guys into 4 groups. And then you guys are going to talk amongst each other about how to make that solution tomorrow. You'll want to have the mass calculated out before we leave. I'm not going to necessarily put, well, I do want to make sure that some people are separated, but let's try it. Yes, please. Dun, 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 dun. And I'm going to let you guys pick them. So if you guys know that you're coming tomorrow, try to pick a room that's not got somebody else that knows they're coming tomorrow, like Mia, Olivia, and Anna. And if you're coming tomorrow, please just try to pick a different room. If you have to pair up because I only made 4 instead of 5, that's fine. Cool. What's the question? Is one group staying here? Can you guys not pick the rooms? You should be able to pick it. There we go. Everybody's picking room 1. I'm gonna have to move. Okay, good. They are splitting up. You guys go to group room 3 or 4 at this point, please. Room 3 or 4.
Mine's not letting me choose a room.
What?
I don't see an option either.
All right, Gavin. And who said I don't see an option either?
Both Gavins.
The Gavin squared. Is it weird if I put you both in the same room?
No, it's fine.
All right. Oh, poor Mia. Poor Mia's by herself. Is spec 20 lab? Yeah, right.
would do is we put 2 molar set equal to an X number of moles over 0.100 liters to find the number of moles we'll need.
Does this room have somebody that normally comes in on these next 2 days?
I'll probably be there tomorrow.
Okay, cool.
Unless something like serious happens, I should be there.
Okay, cool. I just wanted to make sure. I'm trying to get more people in this group. I'll see. Going back out. Paper.
Oh, there he is.
Hey, what's up?
Hi, Mr. Oh, what are we supposed to be doing right now?
So you guys are writing a procedure so that Mia can come in tomorrow and make 100 milliliters of a 0.200 molar cobalt 2 nitrate hexahydrate solution.
Okay, cool.
Does that make sense?
So right now we're supposed to, like, I'm confused. So right now we're supposed to be finding a mass, or
Yep, that's it basically. And then you need to write a procedure.
but aren't we given the mass of the
Nope,
solid?
because we're making 100 milliliters instead of 25 milliliters.
Oh, okay.
That make sense? I mean, you could sit there, well, let's just multiply that mass by 4, you know, but I would rather you try to do it using the techniques that we've done, right? That makes sense?
Yeah, okay.
Cool, cool.
Thank you.
Of the solvent, right, Mr. Jackson? We're trying to find the grams.
Yeah, right? So
Molarity.
we know the molarity is 0.200 molar, and we are making 100 milliliters. We know the powder we're using is cobalt 2 nitrate hexahydrate. We just want to find the mass that we're going to put into enough water to make 100 milliliters of solution.
Oh, so we have to measure both to like get it to be the right molarity.
No, all you need is, well, I mean, in the laboratory, yes, when you're making the procedure, but all you need to say is add enough water to make 100 milliliters, right?
So
Okay.
are we doing the
Yeah, the-
M1 V1 equals
No,
M2
because
V2?
we're not diluting anything. We're making it from solid. So we don't
Okay,
have
so
a
how do
stock
we-
solution. Olivia needs to make the stock solution tomorrow. I'm not stressing you out, am I, Olivia?
I would be lying if I said no.
It's just like Kool-Aid, right? But Kool-Aid tells you exactly how much to add, 1 cup to 2 quarts. You know the molarity that you want, 0.200, and you know you want 100 milliliters of it. You got to find the size of the mass of the solid.
But couldn't we just do 0.2 molarity divided by the grams? Because that would give us how many grams that are in 0.2.
Why do you make it hard? You want grams, which is 1 unit. Start with 100 milliliters and take it to grams like I've shown you, like, right? Like every problem we've done. Can I share my screen? Or am I
Yeah.
sharing it?
You're not.
So if we start with this 100 milliliters, we should be able to use this molarity and just go boom, 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 boom until we get a mass, right?
Mhm.
And that mass will be how much grams you're going to try to put in that solution tomorrow.
Okay, will you do the first step of that problem, please? I'm
Yeah,
really confused.
there are 1,000 milliliters in 1 liter.
Okay.
Could you do another step in that problem? Yeah, right. That's the worst step ever, isn't it?
I know.
What's going next?